Hello class, today we are going to have a lecture on range tracking systems. As we have discussed in our previous video presentation, we have discussed about the angle tracking systems, and a part of range tracking system was also being discussed in that very presentation, but it was not very clear. So as the video time was extending, so I was not able to make you much clear about the range tracking system. So I'm making this specific presentation on range tracking systems. So before starting with this presentation, I would like to know that up till now we have got an idea about the tracking systems. Tracking means to find out the way to reach our target. Track means to find out or to have a proper way out for our target. And for this purpose, we have basically discussed about the various target tracking techniques in a previous presentation or the previous lecture. Now we are proceeding towards our next segment of our lecture, that is the range tracking. What do you mean by range tracking? Range tracking means to track the range of the target. What is the exact range of our target? The target range is measured by estimating the round trip delay. Round trip delay means that what is exact time or the round trip time taken by the radar or the echo signal to move from the transmitting side towards the target and back from target towards the transmitter. So that is a round trip. And what is the delay produced between the transmitting signal and the echo signal? What is the delay in between them? And to calculate that range target or range for a round trip delay, we need to have this formula: R is equal to CTR by 2, where C is the velocity or the speed of light, 3×10⁸ meter per second, and TR is a round trip time. It is actually not a single time, it's a round trip time. Round trip time means a total round minus a trip time. What is exactly time taken by the trip to movement from the transmitter towards the target and from back from the target towards the transmitter. It is taken in seconds. So this was your formulation for this range tracking. Now we move on toward other segment of this presentation that is also very important, but that is known as split gate system in case of your range targets. How we can exactly have that range tracking system? We use this range tracking system by using the split gate system. Split gate system means it is basically of two types: early gate and late gate. Early gate produces positive voltage and a late gate produces a negative voltage output. Early gate means when the wave is approaching from 0 towards the maximum peak, it is a positive voltage. As we've discussed in many of our microwave operations of microwave generators, we have seen that positive voltage is always from the 0 to the positive peak, maximum positive peak, and negative voltage is from the maximum peak of the positive towards the 0 value. That comes under the negative. That we have discussed in our previous microwave generators as negative resistance region. So subtracting and integration is a part of split gate system. Subtracting the values and integrating the values wherever it is required. It depends upon the requirement of our system. Output may be 0, negative or positive. It's quite obvious that when the early gate is approaching, that means we are heading toward from 0 to a maximum positive voltage, it will be a positive output or the positive voltage output. If it is from the maximum positive voltage to the 0 voltage, it would be a negative voltage. And 0 voltage means when it's not approaching to any value, it is stagnant upon a single value as the 0 value. So I hope you have all very much clear about all of these three segments: early, late and 0 voltages, which makes output in the form of positive, negative or 0. Positive voltage is when we have the early gate, negative voltage is when we have the late gate, and 0 is from the stagnant value of the starting point of the transmitter section, that is the 0 point. Okay, next we move on towards the next section. This I will try to elaborate it so that it will be more clear to you people. Split range gate, it's a prediction for the target movement. This is just a graphical prediction for the target movement, how the target is actually moving. This is the first, the first picture, the first graph over here is the first signal movement is basically the radar echo signal. This is the radar echo signal. Echo signal means a signal which is being produced when the target is coming back after striking the target. The signal is coming back after striking the target towards the radar station. That is your radar echo signal. Because this signal, this radar echo signal is basically very important. Why this is important? This is very important because this actually gives us the exact location of the target from the radar station. So it is very important that what the value the radar echo signal is giving us, it will give us the exact prediction that which is the exact track, scanned area, the target area, and the exact location and the distance or the range from the target. So next movement of the wave is the early gate movement. Here we can easily visualize this part of the radar echo signal is the positive part. It is increasing from 0 to maximum peak voltage. So we have this early gate, because early gate we have seen the previous presentation also, previous slide also, previous slide also. Early gate is the positive voltage. Positive voltage means from 0 to maximum peak voltage. And next is a late gate. Late gate means from the peak to the zero value. This part is your negative resistance region, the negative voltage region. So this is elaborating us, or this is predicting us the value of the late gate. Early gate response is in the form of this region. That means it is increasing from 0 to maximum peak value. And late gate response in the form of maximum peak value to the negative value or the negative voltage level. So this is your presentation on the range gates and the location of the target or prediction of the target to find out the range of the target. I hope this presentation would help you a lot in tracking the range of the target. So class, whenever you get this question in your exam, you need to draw these waveforms and you have to tell the formula for the range target. If you have any queries, you are free to ask me any moment of time. Thank you so much, class.